Hello everyone, my name is Daniel Popalsai and I'm the Technical Sales Engineer for Technica Engineering. Today I'm here to show you the demo where I give you the insight about the in-vehicle network and how are we capturing the traffic from different types of buses and point-to-point networks. So let's just dive deep into it. On the right-hand side, I have capture modules. These are our modular systems that capture the traffic from the vehicle. They come in 5 variants. So we have a variant for every technology. We are capturing traffic of LIN and analog signals. We are capturing traffic from CAN, CAN-FD, FlexRay, and serial communication. And then we are capturing traffic based on Ethernet, 100BASE-T1 and 1000BASE-T1. All of this traffic is then logged to our logging system or to our software tool, which is called Andy. We will visualize this traffic using Andy Traffic Viewer, where we will see all this traffic has been captured using one interface on your logging unit. Also, all of this traffic is time synchronized, sharing the common understanding of timing. So let's just dive deep into it one by one. First, I will explain how is this traffic generated. So on my right-hand side, I have our software tool called Andy. Andy is capable of enabling the user to write scripts in Python, where you can send trigger signals, you can write scripts to send messages and frames for different types of protocols using Ethernet, using LIN, CAN, and serial communication. And all of this communication is later logged. So on my right-hand side, Andy is generating some signals. The traffic generation units are actually being triggered, and then they start to generate traffic. So over here, I have our media gateway. Media gateway is an automotive Ethernet capable switch. Now, this media gateway is actually triggered by Andy, and it starts to send Ethernet-based messages, 100BASE-T1 and 1000BASE-T1. And these messages are then logged by the logging part of this demo, which is the capture module. Moreover, I also have a 100 and 1000BASE-T1 media converter MateNet, which is also providing one interface for 1000BASE-T1, which is later logged on our capture modules unit. So all of this traffic is being logged by the Ethernet parts of the capture modules. Now for the non-Ethernet parts, where we are triggering LIN, CAN, CAN-FD, FlexRay, and analog signals, we have these 2 modules over here. One is called FCCP, Flexible Central Computing Platform, and the second one is called BTS Evo. Both of these modules are talking to one another in different languages like LIN, CAN-FD, CAN, and FlexRay. And the capture modules that deals with these technologies are actually tapping into this communication, logging it to our logging system. So all in all, over here, we have our traffic generation. So the triggers are coming from Andy, from the scripting tool, and these modules that are capable of generating traffic are actually generating this traffic. Then on the left-hand side over here, we have our capture modules that are logging this communication. So all the traffic that we generate through Andy is being logged by our 5 capture modules. As I mentioned, we have 5 variants for capture modules. The first one being LIN combo, capture module LIN combo, that logs LIN as well as analog communication. So the triggers or the messages that are being exchanged between these 2 units are actually logged using capture module LIN combo. Then the second one, called capture module CAN combo, is actually logging CAN, CAN-FD, FlexRay, and serial communication RS-232. And then for the Ethernet parts, we have 3 modules. So the first one being called capture module Ethernet combo, which is a combination of logging 100BASE-T1 and 1000BASE-T1 technology. The 4th one being capture module 100 high, and the 5th one being capture module 1000 high. Now 100 high, as clear from the name, is actually logging 100BASE-T1 technology. And the 1000 high is actually logging 1000BASE-T1 technology. Now all this logged traffic is actually aggregated into our next generation switch, which we call Enhanced Ethernet Switch. This is an AVB capable 1000BASE-T1 switch. So all the traffic is actually received by the Enhanced Ethernet Switch. The Enhanced Ethernet Switch is acting as a central part to collect this traffic and then send using one interface to send this traffic to our logging unit. The logging unit being your PC or your logger, whichever, any device that has enough memory to log all your traffic. The cool part is that you can log all this traffic and visualize it using ND Traffic Weaver. So all your traffic, no matter if it's LIN, CAN, if it's Ethernet, if it's non-Ethernet, everything can be logged using one interface in one node, and then you can visualize all of this traffic in continuity. This is the first part. The second part is that all of these technologies are actually using time synchronization. They are using the standard 802.1as. That means that all of them have a common understanding of time. So when the logging units, when the logging network is logging all this traffic, all of this traffic is actually sharing the common understanding, and that means when the logger or your logging node is receiving this traffic, you can visualize in Traffic Weaver or Wireshark the common time stamping at what time, which particular traffic from which particular node, from which particular port of that node was received. And this is the beauty of it, because at the end of the day, you're logging all this traffic, chunks of gigabytes of data, and then you know who sent what when. All this information is logged in using an open protocol called TECMP, Technically Enhanced Capture Module Protocol. Now the beauty of this protocol is it can encapsulate LIN, CAN, FlexRay, Ethernet, serial communication, analog communication into an Ethernet frame. This new Ethernet frame has a header which has TECMP information. This TECMP information actually contains the capture module ID, so you know which node is actually sending this information. It also contains which particular port was used to send this information, so the channel ID. It also has some built-in counters, so you know how many packets were received. And moreover, you also have some timestamping information, so you know at what time was this information received. So you cover all your what, why, who, and when of your logging system. And all of this information is captured by your logging node, and then the logging node can make sense of it. So TECMP being an open protocol, Wireshark is also able to understand it, to dissect this information, to decode this information, and show it to you. Apart from Wireshark, you can also use our inbuilt tool called ND Traffic Weaver, which can give you additional information and more control over logging this information. So this is what the demo is signifying, that all your information is being logged using a single interface on your logging unit, on your logging node, and all of them is time synchronized. Thank you so much for joining in and paying attention to our demo. I wish that this was fruitful. If you have more questions, please feel free to ask us. Visit our virtual booth. And if you have further questions, don't hesitate to email us or contact us through any of the media that's mentioned here. Thank you once again, and have a nice day.